How's it going, nerds? Welcome back to another video of our chapter 1 test review here. So today's video is going to be a little shorter than some of the other ones. As you can see, we will be working on inequality type of problems with absolute value bars on them. So yeah, we're just going to be working on two of them here. There were four, but the other two was just too simple. So these are, the average difficulty amount. So these are the two that we're going to be doing. So again, this video is going to be shorter than most. So without further ado, we're going to go ahead and get into it. So starting with the first one, the absolute value of 2x minus 1 being less than or equal to 3. All right, so in order to solve an absolute value inequality problem, we first have to get rid of the absolute value bars because, again, when we're solving it, we have to solve for the variable. That's what we always do, solve for the variable. It's only what makes it different is, what's attached to it or what is being done to the variable. In this case, we have absolute value bar and, it's an inequality instead of a regular equation. But we can treat it as a equation, but just remember it's an inequality when we keep that in mind. So starting with the first one, so in order to get rid of the absolute value bar, so that's the first thing we have to do. There's a formula for this type. I'll have it pop up here somewhere so you can copy them down along with the others. But for this particular one, or just with absolute value bars in general, for in an inequality, let's talk about absolute value bars. Well, we know absolute value, when we take the absolute value of a positive or negative expression, it's always going to come out as positive. Why is that? That's because absolute value measures the distance of a point from a zero. So that's why when we have the absolute value of 5 and the absolute value of -5, those two answers comes out as 5, because from 0 to +5 is a distance of 5 units. And it's the same for from 0 to -5. It's still the same distance from 0 to -5. It's still 5 unit distance. So when dealing with absolute value inequalities, we will have two different or two sets of inequalities. One where it is the positive version and the other one where it is the negative version, because again, you have two sides that will be the same distance away from our 0 point or center line, if you want to call it that. So the first one, it will be as it is written, just without the absolute value bar. And the other one will be the negative of the 3. So again, the formula, I would have had that popped up already, so you'll know what was supposed to be negative and positive. So when I go to rewrite this, I will have -3 less than or equal to 2x minus 1 being less than or equal to +3. So this is how that inequality will be set up into one line. So I will solve for my variable x. So here, think of this as having two equations just written in one line. So when I go to solve for this, first I need to get rid of that -1. So I will need to add 1, +1, +1, and also I need to do it here. So that will give me -2 here. a 4 here. So it's like I'm working out two equations all together instead of doing it at one time or one at a time. So now I need to get rid of that 2 that's being multiplied to my variable. So we're going to divide it. We'll divide the 2 into the 4 and also into the negative 2. So that way I will have a negative 1 less than or equal to x, which is less than or equal to 2. So I am going to draw a number line. And those two numbers at the end, you can consider those as your boundaries or endpoints. So negative 1 somewhere here and 2 somewhere here. And they're saying that x will be greater than or equal to negative 1, but less than or equal to negative 2. So that means our solution set will be equal to or in between the negative 1 and the 2. So to see that, this solution is correct, let's test it. So we're going to plug in 3 numbers. The 2 endpoints, because of the type of inequality it is. This is a less than or equal to. So that means it can be equal to those endpoints or in between them. So let's check to see if it's correct. So we're going to do negative 1, 2, and any solution in between of the 2. So we plug in negative 1. Will this be true? So 2 multiplied by negative 1 is a negative 2 minus 1. Negative 2 minus 1 is a negative 3. Absolute value of negative 3 is 3. And 3 is equal to 3. So 1 does check out. So now I'm going to use the other endpoint, 2. So 2 times 2 is 4. 4 minus 1 is 3. And the absolute value of 3 is 3. That one is also equal to 3, so that checks out. All right, so now a number in between the 2. So let us choose 0. Let's choose 0 since that's easy enough. Okay. So 2 multiplied by 0 is 0. 0 minus 1 is negative 1. And the absolute value of negative 1 is a 1. And 1 is less than. It does fit this statement. 1 is less than 3. So that checks out. So our solution is going to be all the solutions that work for this inequalities are equal to negative 1 and 2, and also between those two values. So how I have it written on my number line here is kind of how I will write it as my interval notations. So in interval notation, how this will be notated is I will have my 2 endpoints, negative 1 and I'm going to say comma 2. So the comma just represents everything in between my negative 1 and my 2, my endpoints. So what will I have at the end of my endpoints, what will enclose them will be brackets. And the reason why we're using brackets is because our endpoints are included into our solution, because those endpoints does also make our statement for the inequality true. So we have to include those endpoints as well. So that's pretty much it. This is our answer in interval notation. And this is how we would draw it on the number line. So if you're asked to do both, this is how you would do it. All right, simple enough. So next we are going to do the second one, the 2 multiplied by the absolute value of x minus 3 plus 1 greater than 5. So we're going to get to that soon. All right, so I got it written down. So now let us go ahead and solve it. So first thing we need to do is not get rid of the absolute value bars. We can't do that first because there are some things being done to the absolute value bars themselves. So we got to get taking care of those and then do what we did in the other one. So we need to get rid of the things that are being done to the absolute value bar. So that is the plus 1 and the multiplied by 2 pieces. So we got to get rid of those 2 pieces. So first thing first, we will need to get rid of the plus 1. So minus 1 on both sides of this inequality. We will have the 2 multiplied by absolute value bar of x minus 3 greater than 4. Next, get rid of the multiplying by 2 by dividing it by 2 on both sides, so the inequality. So now we'll just have the absolute value bar of x minus 3 greater than 2. So now with this one here, this is a greater than inequality. The reason why I pointed this out is because how we will write it into 2 separate inequalities will be different than how we did the other one, which was a less than a type of inequality. So there's a difference. So that's the reason why I put up that formula. So you will be able to notice the differences between the two. You could have, if you want to go back, you can, and pause the video and copy it back down if you hadn't done so already. So you can be able to tell the difference between a less than absolute value inequality and a greater than absolute value inequality problem. So in order to get rid of the absolute value bars here, again, we're doing the same thing. We break it up into the 2 different ones, the positive and the negative. It's just we won't have it written as one line. It'll be literally 2 separate inequalities. So the first one is going to be the inequality that we have already, just without the absolute value bars. So x minus 3 greater than 2. And then the other one, x minus 3 less than negative 2. So we have our 2 different inequalities, and we're going to solve both of them. So here we adding 3 to each one. X greater than 5. Then this one will be x less than 1. So since this is a greater than problem, It's what we will call a or type of problem, OR. The previous one, since it was a less than problem, we call those and problems, AND. And in order to remember, you can listen to the inequality signs when you're saying it. So less than and greater or. So less than problems are and problems. So that means your solution is in between your two endpoints or what overlaps. And your greater, your or problems, they don't overlap. They usually are solutions that are going in opposite directions of your endpoints or your boundaries. So in this case, this is what we should see. Since this is a or problem, our solution should be going opposite ways of these two endpoints of the 5 and the 1. So let's see. I'm going to draw my number line. My 1 here and my 5 is here. And it's saying in the first one, x greater than 5. So that will be going to the right of 5. And then the other one, x less than 1. So that would be going to the left of 1. So yeah, that's how it looks. So let's see if those solutions are correct. Now here, I will not test the endpoints 1 and 5 because this is just a greater than problem, not a greater than or equal to problem. So if it was a greater than or equal to problem, then I would plug in those to see if it comes out correct, but it's not. So those endpoints I will not test, and they will not be included into our solution set as an interval notation. So the original problem was here, 2 multiplied by absolute value x minus 3 plus 1 greater than 5. So I'm going to plug in numbers that are less than 1 and greater than 5 and see if it checks out. Okay, so number less than 1, that's 0. So I'm going to plug that in. Let's see if that will be greater than 5. So 0 minus 3 is a negative 3. Absolute value of negative 3 is a 3. 2 multiplied by 3 is 6. 6 plus 1 is 7. 7 is greater than 5. So every value less than 1 will check out. So now value greater than 5. Let's use 6. So I'm going to just go ahead and talk it out while I'm erasing this here. 6 minus 3 is 3. Absolute value bar of 3 is a positive 3. 2 times 3 is 6. 6 plus 1, again, that's 7. So again, that checks out. So all of my solutions that are less than 1 or greater than 5 will make this solution or make this inequality statement hold true. So in order to write this as an interval notation, let's go back to the number line. So we know on the number line, the numbers just keep going and going, right? So if we had our, if we had, 0 as our center line, we know every number to the left of 0 are negatives and every number to the right of 0 are positives. And if they just keep going and going in both directions, then it's almost as they are seemingly approaching the both ends of the infinities, the negative and the positive infinity. So that's what I'm going to label. Further down the line to the left is our negative infinity, and further down the line to the right of our number line is the positive infinity. So I'm going to need these when I'm writing my interval notation. So with that, for our first half, our solution will be from negative infinity to a positive 1. And then the second half will be from 5. It always goes from smallest to greatest to positive infinity. Now, in order to join or conjoin these two solutions into one, we will use a symbol called a union, and it just looks like a capital U. So we are just joining these two separate solutions together into one. And notice how I have parentheses all around earlier, because as I said, the 1 and the 5 are not included into the solutions because it's just a greater than problem and not a greater than or equal to problem. So they are not included in our solutions. So you use parentheses whenever a value is not included and brackets when the value is included. Other reason why we have parentheses are around the infinities. You always have parentheses around infinities because we can't reach infinity. If you try to, you'll take a long time, needless to say. But yes, that's why we have parentheses around infinities, because you can never really approach it. So those will always have a parentheses around them. But your actual finite number, a number that you can actually count to and stop at, those will be included or not included depending on what the inequality is. If it has an equal to sign underneath, then you will use brackets to be included. If it doesn't have it, then you will use parentheses, not included. So that would be it. Like I said, that was the last problem. Next video, we will be going into word problems. Now, those won't have a specific concept going into. It'll most likely be a mixture of the other stuff that we've been doing just now in word form. So I'll probably pick maybe 3. I won't go over that. If I do 4, then the video will may be a whole lot longer than the other ones. But yeah, so next video will be word problems. Okay, here's what I'll do. I'll do 4, and what I'll do, I won't solve it completely. I'll just go through on how you are supposed to pick up your different, keywords that you need to use to let you know what kind of problem this is, so you can transfer it into the math, to the numbers and the mathematical expressions. And then from there, you should be able to solve it. So again, with that being said, I'm going to go ahead and end this video here, you guys. I hope you enjoyed it. If you did, you know what to do. Like, share, subscribe. Get this out there to all the nerds in the universe, multiverse, and alternate dimensions. And I will see you in the next one. The Immortal Nerd, signing off.